Today we're going to talk about how to design a zone system. In our series of videos that we've been covering zone systems, we talked about how to wire it, the do's and don'ts, things that are commonly missaid and misunderstood through all the years that zoning has evolved and how equipment has been updated and trade practices have changed to mitigate compressor failures and provide more comfort through those controls in those houses or places of business. It's always important to one-up our knowledge so we can carry on within the proper timeline on what's today and what was yesterday, what was 10 years ago, whatnot. And so in today's video, we're just going to dive right into that next segment of how do I design a zone system? If I were to just look at a zone system that was potential in a home, how many dampers would that take? How would that pretty much look as an example? Going from something that's already ducted out to redesigning it with dampers so they can control sections of that home. Stay tuned. Okay, so we don't have any labs today. We're just going to go right to the smart board. We're going to get right into it. How to design a zone system. We got to identify a few key components. These trapezoid boxes, these are your color-coded blue and color-coded red right here. These are your distribution boxes or mixing boxes. They're pretty much the same. That's just, if I were to use this as a main distribution box, then I know that that's going to be the closest mixing box to the air handler that's distributing the majority of my trunk lines, right? So if I said a main supply air distribution box, I would think, okay, that's going to handle a trunk line going over to certain areas of that home. Or if I said a supply air mixing box, granted it can be the same size box, doing the same job, it's just probably handling more takeoffs that are going to those small vents throughout the house, bedrooms, bathrooms, living spaces. Over here, we have the same boxes. They're color-coded red, and I have a return air distribution box. That would be pretty much distributing the trunk lines again. And then I have a return air mixing box, same type of box. I'm just, terms and definitions, we're just notating that this one would probably have the return vents that are in the bedrooms and throughout the house hooking to it. And when we're zoning out a house, we have to consider both supply and return. Because we have to involve bypass ducts. And bypass ducts are basically a damper that will open up based on static pressure to allow air back into the return side so it can circle back around and not cause excessive static pressure built up that can hurt motors and potential lose compressor oil inside the compressor because of not having enough airflow on the evaporator coil. So by taking air out of the supply because dampers are closing down, then that will allow that air to be circled back around to the coil. Granted, it's cold air, and we'll get into that, but it will allow that air handler to not struggle to breathe. So we start closing these dampers down, we start having issues when we don't have bypass. So it would be not wise for us to just talk about the supply dampers without involving the return system and how that supply trunk line that comes over to that will bypass air that's not being distributed back into the house. So we're going to cover that. I'm going to go ahead and get into how to design a duct system. This is an easier way of looking at it because all I've done is I've taken these rectangles. These are boots. These are return boots, mixing boxes throughout the home. And I haven't put any lines on anything, so you don't know where trunk lines are going. You don't know where takeoffs are going. And so this is a very easy way of looking at it. But a lot of the times when you get out to the house, it's already been done. All right, so there is absolutely no dampers in this at all. They have supply distribution boxes, and then they have these supply mixing boxes everywhere with the smaller lines, which are the takeoffs that go to the individual vents that I have labeled throughout this home. This is a bird's eye view looking at it. And then I don't have any walls here, anything like that to outline where the size of the rooms and all that. This is not a a load calculation that we're trying to do here. This is just bird's eye view. If I was in an attic and I had to go up there and map out how many boxes do I have, how many boots do I have, bird's eye view, where are the lines coming off the mixing boxes now, and then this customer wants to design a zone system with this, what would we do? How would we take this design without replacing everything and without starting from scratch and utilize as much of this as possible and just rework it so it can be zoned out? And that's what we're going to cover, because this is your most practical zoning application, where a customer just says, hey, I've got my kids here, they want one temperature. In my master bedroom, I got to have another temperature. I just moved in my mother-in-law, she's a little older and she likes it at a certain temperature. We're not always hanging out in the living room. Maybe the house is not being as lived in as it once was, where family members have now moved out. Birds left the nest. They spread their wings a little bit, and now they don't feel like the entire house needs to be conditioned all night long while they're sleeping. So maybe they wanted to shut some of this down. There's lots of reasons to zone out. We have to cover some of the fundamental things first before we get into putting in dampers. And what I mean by dampers, I'm dealing with dampers. You got a damper motor, which is going to energize the damper to close, and I have the damper inside the actual collar here that goes onto the mixing box that will shut down once it's energized to not let air pass through that. So we're not putting these on the individual vents. We're actually putting these directly on the mixing box, and we have to design it to where we shut air off to a trunk line. For example, if I wanted to zone out this box, I would put a damper on that trunk line. If I wanted to zone out the rest of this, I'd put a damper here. And we see this a lot, but that doesn't mean it's done correctly. If the goal or the intention was to zone out all the bedrooms on one zone with the exception of the master bedroom, that needs to be on its own zone, and then put everything on the house on another zone, then I have just been tasked with 3 zones. Bedroom 2, 3, and 4 would be one zone. The entire house would be another zone, and then the master bedroom would be a zone on itself. And some people say, well, if you zone out that master bedroom by itself, that's only 3 vents. If we say the bathroom into 2 vents here, that's not enough. And that's not true. I think that's a little excessive to run a whole system just for one room. I would incorporate all the bedrooms, but if that's what they want, it's perfectly fine. It's their home, okay? That's what they want. How do you do it, and how do you do it safely? So it doesn't matter what the customer wants. You need to know how to make it happen, right? And so we have to get into rearranging these takeoffs, adding a mixing box or taking a mixing box away if needed, and making sure that we're putting supply air dampers on trunk lines so it could work correctly. So the first thing we need to do is we need to find out how many CFMs do we have, because when we're calculating damper sizes, we're calculating it by a trunk line. So if you're going to do a redesign, you have to know, what do you have currently there now? What is your plan? How are you going to utilize the existing material? And then how are you going to add dampers to that so you don't have oversized trunk lines or undersized trunk lines for those zones? So we're going to go ahead and just put some numbers on these that will represent the diameter of the flex lines. We're going to get a quick calculation on that CFM, just a quick rule of thumb that I use, and then we're going to write the value of what those CFMs are inside these boxes. We're going to add them all up, and we're going to see what our total CFM should be, and then we're going to start to break down how we would rezone this example. So getting right into it, I'm going to go ahead and use black. It's going to show the best. All right, so the master bedroom. I have 3 vents in the master bedroom. Let's just simplify this. We'll say that these are 6 inches in diameter, and we'll say that the bathroom is 4 inches in diameter. And I have this living room vent here for living room vent number 1. Coming off of this box, of course, I have the second living room vent coming off a totally separate box. All right, so say that this living room vent here was a 7-inch. Okay, so that's everything for this box. So if we were to just do a quick calculation, we'll say 120 CFMs, 120 CFMs, 150 CFMs for the 7, and we'll say 40 CFMs for the bathroom. See, 5, 9, 10, 11, 12, 13, carry the 1, 4. So we have 430 CFMs. So I'm going to put 430 in that box. I'm going to go ahead and erase my math. We'll have other videos where we talk about airflow and CFM calculations and all that, and the Tom sweet spots. And so that's not on today. So we're just going to assume that, however you chop this up and watch your videos in what order, this is just where we're at right now. The dining room, kitchen, laundry, and office, that's coming off of one box. We need to quickly identify these 4 vents are coming off this one box. So let's just say that the kitchen was a 7-inch, the dining room was a 6-inch, the laundry room was a 5-inch, and we'll say the office was a 6-inch. So those quick CFMs would be 120, 150, 50, and 120. We're going to go ahead and add that up. 0, 5, 6, 7, 12, 13, 14. So we'll say 14, carry the 1, and we have 440 CFMs. So we're going to write 440 CFMs in this box. Let's go ahead and erase our math. Okay. All right. So far, I hope our equipment is at least 2 tons, 2 to 2.5 tons, because we have 870 CFMs. There's 400 CFMs per ton nominal. All right, let's go ahead and get into this third box here. I've got 4 vents coming off this one mixing box. We'll say bedroom 2, let's just say that's a 6-inch. Let's say bedroom 3 happens to be a 6-inch. Say this living room here happens to be a 6-inch, and this family room happens to be a 7-inch. So we'll go ahead and do the math on that. We have 120, 120, 120, and 150 CFMs. 6, 6, 6, and 7. Okay, so we'll say 0, 11, carry the 1, 1, 2, 3, 4, and we have 510 CFMs. So we're going to write 510 CFMs here, but now, before I do that, I need to add this box here because this box is also feeding that box. So we're going to bring that 430 CFMs down. We're going to add that up. That's going to give us 940. So the real value of this box is its own takeoffs plus the trunk line that's feeding this box here, which is this box needs 430 CFMs. So adding that together, we have 940 CFMs. So let's go ahead and erase our math. And again, I'm not trying to give an airflow class right now. We're trying to give a zone design class. Now you get to see what you get to tune into next time as we start to release videos. A lot of knowledge here. All right, we have 2 vents left, and they are coming off that main distribution box. Why is it a main distribution box? Because this mixing box is only distributing, one trunk line and a bunch of takeoffs. But this is distributing 2 trunk lines. It is carrying the load of the entire duct system, plus it has 2 takeoffs. So I would say this is the main distribution box. So I can identify, okay, well, dampers are definitely going to have to go on this box, right? So let's just say this bathroom is a 4-inch, and say this bedroom over here, let's just say that this is a 7-inch. Why? Because it probably has 2 exterior walls with 2 windows. It's going to have a little bit more of a heat load than this box here, or this vent here that has a 6 on it. So we're going to say that that's a 7-inch, and see what we get there. So I have 7, that's 150. Get my marker out. I got 150 CFMs. I have 40 CFMs for my 4, and then I have 940 CFMs, right? And then I also have 440 CFMs. So that main distribution box is carrying the load of all of that. So let's add that up. We have 0, 8, 12, 12 and 5, we have 17, carry the 1, 9, 10, 15. So we have 1,517 CFMs. So the value of this box is 1,517 470 CFM. So I hope that I have a 4-ton piece of equipment working on all that, because if I had smaller than 14 or 4-ton, like if I had a 3.5-ton, which is 1,400 CFMs, or if I had a 3-ton system that was putting out 1,200 CFMs, then this would be oversized. So that's why it's very important before you get started to find out what do you have. Because if you're going to be there fixing it, this is the time to take care of anything that's oversized and fix it all. You owe that. So we're just going to make this simple and say, hey, we had a 1,600 CFM air handler. It was 4 tons, and it's right within its thing there. Now, we'll get into other videos, like I said, where we do airflow and we talk about oversized and undersized, and I'll give millions of examples if we have to, until we all feel like we just understand it. So if I have 1,500 CFMs coming to it, then basically, 1,570 CFMs leaving the machine, I have to have about 1,600 CFMs returning. So we're just going to say that this is 1,600 CFMs. Let me write CFMs here. And by the way, the air this is coming back because it's return. This is coming in because it's supply. All right, blue for supply, red for return. Red hot, blue cold. All right, so we're going to say that this one duct here would have to be right at, pretty much this would have to be like 18 inches. This obviously would be 18 inches. So we're going to say this is 18 inches, and we're just going to say this is 18 inches here. Okay. So what size trunk lines would I have here? Well, if I had 440 CFMs, I'm going to pretty much put a 12-inch in here. If I have 940 CFMs, I'm pretty much going to have a 14-inch here. And then if I'm feeding this 430 CFMs, I'm going to have another 12. So I'm going to have two 12s, a 14, and an 18 coming back to the unit on both of them. That's pretty much how that would work. So now we have to say, hey, we want to zone everything out. So let's take this and let's just go back to this. All right. We're going to refer back to what we've got and what we're going to do. This is the best way to do this, so we have a nice clean image to compare to. All right. So first, let's go ahead and just run. Let me go ahead and get a bigger size mark on this. Let's go ahead and run. Oh, come on. There we go. We're going to say there's our supply coming in. That supply coming in, it looks like everything over here doesn't really have to be altered that much. So getting right into it, I'm going to say that my trunk lines are the first thing I need to map out, not the takeoffs. Okay. So what I'm going to do is I'm going to say if I wanted to have a 3-zone system, then I would take advantage of these mixing boxes, and I would pretty much say I want to take this out of here, and I would say I'm going to take this one out of here. That would be the easiest way to just quickly identify how can I do this utilizing the mixing boxes that I have. And if I did that, I can simply just put my damper here, here, and here, and then I would have a thermostat in each one of those 3 zones that would control all of that. So I'm just going to go ahead and say with different colors, we'll use purple, for example. This zone here, we'll just say that is the main area. Well, what is the main area? If we go back to what the main area was, we knew laundry room, office, family, living, kitchen, and dining room. That's all the main area. All right, so that's a lot of ducts that have to come off of that one box. So we're pretty much going to say that this one needs to come off, this one needs to come off over here, this one needs to come off, and then we need to pretty much put all of these also on this box. So that's going to be a pretty big trunk line. So if we looked at that, A lot of this is already coming off of it. So I'm adding two more ducts. I'm sorry, looks like three more ducts. Let's just look. Yeah, three more ducts. Okay, I've got four. I need to have a total of seven. So I need to put these two living rooms and put that family room on that box. Well, I could add more to that box. That's not a problem. I'm adding this family room to this side, and I'm pretty much adding these two living rooms to this side. Okay, but if I looked at that 12-inch trunk line that's feeding over here is not going to carry the additional loads. I already know that 12-inch trunk line is going to have to come out. All right, so let's just go back, and we're just dealing with that one zone. So we're going to call this zone. This is the main zone. That main zone. All right, and so let's go back and we'll say in black, oops, this was a, excuse me, we had a 6, a 5, a 7, a 6, a 7, so it's at 2 7s, 3 7s, so we have 3 7s, 3 6s, and a 5. So we had a 6, we had a 7, I believe this, okay, so the kitchen was a 7, the living room up here was a 7, let's go back. All right, so 7, this was a 7, and this was a 6. This family room here, this was a 7, this was a 6, and then this one here, this laundry room, was a 5. Okay, so we had 3 7s, 3 6s, and a 5. So we're going to recalculate that. All right, so we have 150 per 7. We have 120 per 6. And we have 50. We have 50 for that 5. So we have 0. Let's see. We have 20, 26. Carry the 2. 1, 2, 3, 4, 5, 6, 7, 8. So we have 860 CFMs in that zone. So I'm going to write 860 CFMs. Let's go back and erase our math. Okay. All right, so now we're going to size that trunk line. All right, so I had a 12 there. 12 is not going to carry more than 650 CFM, so I'm going to go ahead and step that up to a 14. So now that 14 will be the size of that trunk line. So if you look at that, excuse me, it's a big difference. We took 3 vents off of between 2 boxes, and we've added it over here. We said that's going to be our main now, and we took that 12-inch trunk line out, and we were able to do that. So we just need a little bit of 7-inch flex, a little bit of 6-inch flex, a little bit more 7-inch flex, and replace that one trunk line to a 14, drop a damper in there, and now that zone went from 440 CFMs over to 860 CFMs. That means that damper is going to be a 14-inch damper. To give you a perspective on how big a 14-inch damper is, this is how big a 14-inch damper is. Okay. All right, so we're going to go ahead and take this zone over here, and we're going to say that is just going to be for that master bedroom. All right, so we're going to go ahead and pick a different color. We're going to say orange. Matter of fact, let's go back to here. Okay, that's orange. We'll make that one black. There we go. All right, so we're going to drop these vents back onto that box. The only thing we've taken off of that box, I believe, was that 1.7 for the living room. which is correct. So that was the only correction we had to do there. And so that zone is now smaller. We're going to go ahead and write down what those sizes were. We had 2 6s and a 4. All right, so we're going to say this is a 6, this is a 6, this is a 4. Let's go ahead and do some math. 120 CFMs per 6, 40 CFMs for the 4. This is Tom's sweet spots. 4, 5, 6, 7, 8, 280 CFMs. So now this zone is only getting 280 CFMs. That's what the customer wanted. They wanted to have that zone all by themselves. Go ahead and erase for math. And now we have to size a trunk line for that. Well, if you looked what we had originally, we had a 12-inch going to it. But now we have dropped those CFMs below 350 or below 400 and something CFM. So now we're in the range of only needing a 10-inch. So we're going to go ahead and say that this is a 10-inch, and that will be a 10-inch damper. And so we have a 14-inch damper, a 10-inch damper, and this will have to be a 10-inch trunk line. So the 7 that we pulled off of it dropped 150 CFMs off that box, which now we don't need that trunk line. Even though it was already coming off of here, we brought it down to here. But that doesn't mean that you can take the 12 off of here and splice it and come back here, because then that zone will be oversized. You need to size it for the CFMs that are going to be on that box. We know we have 280 CFMs, and then 10-inch falls within that because we'll get 350 CFMs at a 0.5 static pressure on that flex, and that's how we're going to do that. We have one zone left. Pretty much, we just need to cover these other bedrooms, and why not go ahead and throw that bathroom on there too. So we're going to go ahead and pick a different color. We're going to say that we want to use pink. We'll go ahead and use pink. Let's see here. Let me go back and we'll make that one black. Make this one pink. Okay, so I'm going to take this one and I'm going to move it around to this side of the box. I'll go ahead and take this one. We'll move it around to that side of the box, and then we'll take these other two and we'll bring them over to here. And I'm not trying to show you how clean this should look. I'm just trying to show you where they should go in the box. Obviously, if your airflow look like that, you're probably going to have some serious issues. But again, we're not trying to get into how ductwork should look. We're trying to get into how we size things and calculate. How do we design a duct system? You cannot design a duct system without first understanding what the customer's concerns are, and then past that, what is the CFM calculation and where is it going to be when I'm done? All right, so we know the sizes of these. Go back over to this page. We had a 4-inch, a 7-inch. We had a 6-inch and a 6-inch. So going back, we're going to go ahead and say that this is a 7-inch, a 6-inch. This also was a 6-inch here, and that this bathroom here was a 4-inch. So let's go ahead and do the math on that. The 7 is going to give us 150 CFMs. The 6 is going to give us 120 CFMs. The other 6 is going to give us another 120 CFMs, and that bathroom is going to give us 40 CFMs out of that 4. Let's go ahead and add it up. 0, 4, 9, I'm sorry, 8. 8 and 5 is 13. Carry the 1. We have 430 CFMs on that zone. So 430 CFMs on that zone. So let's go ahead and erase our math. Okay, what size trunk line do I need here? Well, what did we have originally? Will it work? Well, no, we had a 14 originally. So no, I'm sorry, that's not going to work. So we're going to have to size this as a 12. So we have a 12-inch trunk line, 12-inch damper. Over here, we have a 10-inch trunk line, 10-inch damper. And over here, we have a 14-inch trunk line, 14-inch damper. So we just rearranged where the takeoffs were going on different boxes, replaced the trunk lines, rerouted them back to the main distribution box. Everything else just a normal mixing box here. And then if we just look at our colors here, we got the main zone. We have, we'll call this one zone 2. And so This top zone here will be zone 3. And we'll go back to purple and call that main zone, zone 1. So we have zone 1, zone 2, and zone 3. So the next part of this is a little tricky. And so in doing this, we have to understand bypass, because we have achieved how to distribute very efficiently the right amount of CFMs per zone. But what happens when the master bedroom is calling and it's 1 o'clock in the morning and there's nobody in zone 2, right? So those 3 bedrooms, there's nobody there. There's nobody using the hall bathroom. There's nobody in the family room, the living room, the office. There's nobody in the kitchen or the dining room. So the main zone is pretty much set for, like, say, 78 degrees. Zone 2 is probably set for 80 degrees in cool mode, of course. And zone 3 might be set for 70 degrees. You know, sleep comfortable. So this is the only zone that's running. So what do I do if this is the only zone running? For one, it's my smallest zone. So my largest zone is my main zone. My second largest zone is zone 2, but my smallest zone is zone 3. So I have to size my bypass according to the size of zone 3. So that doesn't mean I need a 10-inch bypass. What that means is if this is a total of 1,570 CFM, so we're going to go ahead and write that in here, because that number did not change. Even though we changed all this, the 1,570 CFMs, that did not change. Okay? So I have 1,500 CFM. So let's just look at that for a second. This zone is 860 CFMs. This zone over here is 280 CFMs. Zone 2 is 430 CFMs. And so what I simply need to do is just say if 430 CFMs and 860 CFMs were closed, that will be the size that I need to bypass air back to my return. So let's just add that up. If I said 430 plus 860, that's 9, 9, 8, and 4, that's 1,290 CFMs. And so I'm bypassing just over 3 tons of air. So if this is a 4-ton unit, I've got pretty much just under 1 ton of air coming over to here. The other 3 tons needs to bypass. So my bypass, if I'm sizing my bypass will be sized off of 1,290 CFMs. This is what we mean, because if I add 280 CFMs to this number, I get back to 1,570. If I take 1,290 CFMs off of this because that zone closed and that zone closed, and this is the smallest zone that's open, then I need to bypass the remainder of CFMs that can't go anywhere. So that would be 1,290 CFMs worth that's being bypassed. And so we're looking at a pretty big trunk line. We're literally looking at almost a 16-inch bypass damper. And so if we were to put a 16-inch bypass damper on that box, it's not going to fit. So we would have to introduce an additional mixing box, and then we would have to redesign this. This is one of those things that you're not going to know until you start to step back, calculate, look at, design it without it, and then you have to solve the last part of the equation, which is your bypass. This is a huge fundamental step that a lot of people miss. Now, this mixing box here that's on the return side, I can simply say that, okay, my return's coming in here. This is going back to the unit, my trunk line. I could just come out of this box directly over to here, but I can't. And the reason why I can't is there's no room on the side of this box to sit there and take a damper that's literally going to be 2 inches wider in diameter than this 14 and fit on the side of that box. And then put a 10-inch on. It's not going to happen. And so we would put an additional mixing box right here, just like I cut this in. I spliced that in. I would go ahead, because typically you would just have this trunk line coming off of this 18 going right to the unit. We have a mixing box that's doing that. It offers a side, which is great. However, we have to put a mixing box in right in this area where basically we're coming out with a larger trunk line hitting that mixing box, and then we're going to the 10-inch trunk line. So I'm going to show you that right here. And so if we had to do a bypass, how would we do that? Okay, so we had the bypass that was coming over here. I'm going to go ahead and just move some of these around. Matter of fact, I'm going to go ahead and delete this one. We'll go ahead and move this one out of the way. We're going to go ahead and take this. We're going to go ahead and clone that. We'll come over to here, and we'll just kind of put that one back over here. This one here, we'll go ahead and bring it down. I know these are very large. I'm doing that so I can express dampers. But pretty much what we have done is we've taken these dampers and we said, I'm going to pretty much come in like this. Go ahead and just move that down, create a little bit of space. So we got these dampers here. So I've got one damper going to this box, one damper over here. Let me go ahead and clone that. We'll come over here. Okay, right? And obviously these boxes aren't this close. This is the size of the screen that I'm working with, so I can keep these images big so you can see the content that I've written inside those boxes. We have damper 1, 2. We have another damper over here. We're going to go ahead and clone that, bring it around. And this is pretty much sitting right about in this area. Okay, matter of fact, let me go ahead and just move this out the way. I'll just put it over here. Yeah. Just move this up. There we go. All right, so going back over to our image, we have our 3 dampers. Okay, this is the box, and then we have these other 3 boxes that we're trying to put dampers on. Those are those 3 boxes. This is the main box, so these are the 3 dampers that we just drew. This is that return box that I was telling you is great if we put a bypass on there. And then I told you that we can't really add a bypass because we don't have enough room on that side to add 2 dampers. So what we would do is I'm going to go ahead and take this damper. Go back. I'm going to take this damper and just kind of move it out of the way. And what we would do is we would wind up just taking another box, and we just kind of just pretty much put it over here. And then what we would do is we would take this damper, and we could, I know you don't want to work too far away from the equipment, but you could basically take this damper and just put it on this zone. Okay, pretty much the same thing, right? Move this box out of the way. And what this box allows us to do is this box allows us to confidently insert a trunk line pretty much coming out of it. which we'll draw some trunk lines here in a little bit, and then allows us to take a bypass and put that bypass where it needs to go. Very confident. Let me just move these mixing boxes around just a little bit more. Okay. All right, so I'm going to go ahead and just take, and we'll say purple is going to come in and land here. And we said this was going to be a 14. All right. We have the supply box is right up front of the main supplier distribution box that had a damper going to it. I believe it was a 12. Yes, it was a 12. So, and that color we were using there was like a pink color. So we're going to go ahead and just change that color out. We're going to say that this is that zone. So just to come back, color this in a little bit more. This was the main zone here. We're going to go ahead and label it. And that was zone 1. And then we had the next zone here, which was a 12-inch, and that was zone number 2. The one over here, we used the color orange. We're now taking that out of the front of this mixing box here, and we're saying that that is a 10-inch, and that is zone number 3. Okay, and then we're going to use a different color. We're going to say let's go ahead and do blue. This is no damper. This is just a trunk line. And this trunk line is there to carry the sum of what is going to be absent to allow that bypass to open up based on static pressure. So basically, if this is going to be a 16 coming to here, then I need to be 16 going to it. So we'll do the math on that to make sure that's accurate. If I had this only zone open and zone 2 and zone 1 were closed, then I know this is 280 CFMs. Let's just go ahead and put some marks back on it. So we have 280 CFMs. I don't want to forget this stuff. What do we have here? 430 and 860. We have 860 CFMs. I believe the other one was 430. Let's just check that real quick. Yeah, 430 CFMs. Okay, so 860, 430. If that's gone, we have to be able to bypass almost 1,300 CFMs back to the unit. We can't do that with 14 because it's only going to carry up to 1,000 CFMs. We need to be able to do that with pretty much a 16, which is up to 1,500 CFM. So now, if I'm going to have a bypass here, I need to put a damper on here. So I'm going to go ahead and just clone an image. So before I do that, I'm going to move this out of the way. I'm going to go ahead and just clone this. Where did we put it at? Where did it go? Okay, it's not going to let me. So what we'll do is we'll just go ahead and draw that in. So there's going to be our bypass. We're going to go ahead and label it. bypass. And we're going to say this is 16 inches. And that 16 inches is going to come right over to the return. It's going to say red for bypass. Okay. And anytime that this is the only zone calling, then that air can't go anywhere else. So it's going to come this way, but the excess air will open up that bypass. And then this is already coming back to the unit through its trunk line. So we're going to be returning the sum of 430 and 860 CFMs. Just because we have 16 doesn't mean it's going to open up and allow 1,500 CFMs and rob, this zone of the other 100 CFMs out of the 1,600. It's not going to do that. It's only going to give you what it's got. That's why it's very important to size everything and understand what your CFMs are, so when you're doing it, this all works flawlessly. It all works flawlessly. So there is no damper here. This is just a trunk line. Now we have to figure out what is that trunk line, because that trunk line has to carry 16 inches, plus it needs to be able to carry the 10 inches. So basically, it's very simple. It's going to be 18 inches. So we're going to go ahead and just write 18 inches here, and that's just a normal trunk line. That is not a damper. Now, yeah, I can have 18 coming in, 18 going this way, but just because I have that 18 coming over here, that doesn't mean that I'm going to be pushing here. The only way I can push this open is with static pressure. If this damper and this damper are wide open, I'm not going to have the static pressure to open this bypass. It's just not going to happen. And all I need is 280 CFM. So if all three of these zones are calling, in this design, I have 18 coming in. I'm going to go ahead and just, what to say, we have the air coming in. Okay, we're going to call that 18. Okay, total CFMs is 1,570 CFMs, right? All right, that means I have my return duct coming back to my unit, and it's also going to be 18 inches. So if I have 18 coming in, sitting on this mixing box with these two dampers closed, then 280 of those CFMs will come into here. I'll bypass the remaining 1,300 CFMs roughly, and it'll come back through here. And, yes, that's a lot of air that's coming through this. But at the end of the day, I do have a return duct that's over here. That's a main return duct. So, I'm not going to be pulling, say 1,600 CFMs from my return plus the additional CFMs here. The unit can only move that total volume of air. So if I have 1,600 CFMs that is moving through there, I can't move any more than that. And so it's just going to take more of the supply air and less of this return air, which is why it's very important to start having controls put in your supply air plenum. So when that temperature starts to drop down, there's not enough heat on that coil to boil that liquid off, so you don't return back in a liquid state to that compressor. You want to make sure that that discharge air temperature sensor can cycle, can tell that zone board that it's reading a low limit, so it can cycle off that condenser unit and put it into a 5-minute time delay. Basically, after 5 minutes, if one zone is still calling, it'll just come back on automatically. It just turns it off, kind of starts the clock for 5 minutes before it brings it back on. That gives just enough time for when that condenser shuts off, for that coil to warm up a little bit, and that zone may even shut off while that DATS has shut that condenser off. See it a lot. This is just a very simple way to take something that looks very complicated. We'll come back over here and say, hey, it's already working the way it is. Everything's great. It's got a 4-ton. Everything's already balanced. Maybe need to hang it a little bit better, make it look prettier. But at the end of the day, everything mathematically is working fine. How do I take this, give the customer what they want, and allow the system to bypass the remaining trunk lines when they're in the closed position? And like I said, you always take your smallest zone. In this case, I have a 14-inch zone, a 12-inch zone, or a 10-inch zone. Or I can sit here and say I have an 860 CFM zone. If you want to be more technical, I have a 430 CFM zone, or I have a 280 CFM zone. So my smallest zone is obviously 280 CFMs. Therefore, that's my smallest zone. If that's the only zone open, then I have to return back to the unit the 430 CFMs and 860 CFMs, and I have to do that through a bypass duct. And by doing that, very simply, we've just kind of sketched out a design that will pretty much work. That's it. I can't sit here and tell you every scenario. I just try to find one that was very practical. And yes, I will go over some more airflow stuff, because you're probably thinking, how the heck did he just throw these numbers off his head? Because I've been doing this for a long time, which is why I can stand in front of you confidently and explain what I know so it can help you out. So listen, like I always say, share this information. There's a share button right there. Pass this on to your buddy. Pass this on to a friend, a coworker. If you can't explain it the same, that's fine. You're still learning it. Don't hold back this information. If you say, hey, I found a guy that can kind of help out a little bit, here's his channel, share that. Support our channel by liking it, giving us a thumbs up. Make sure that you leave a comment. I read those comments. I can't get to everybody right away, so I'm not trying to be your tech support. I'm trying to teach. I don't have a curriculum that I'm shooting from. This isn't your traditional style of teaching. This is more, hey, I've been in the field. Here's 25 years right here at the table. Hope I can help you out with it. Subscribe to our channel if you haven't done so already. We need that. It supports our algorithm, and we want to grow our channel. Thank you. Stay safe and stay tuned.